Hello and welcome back to Clarkenomics. In this video, we're going to talk about excise taxes. So the first thing about excise taxes is that they are simply a tax placed on a specific thing by the government. So don't get too confused about the word excise, not exercise, just excise. And think of some examples. So think that the government says, all right, if you buy this, or if you're a company, if you produce this, you're going to pay this tax. Some common examples that we see in the real world would be things like gasoline. So people who buy gas have to pay taxes on it, and that money is used for things like road upkeep and stuff like that. Or cigarettes. The government taxes people when they buy cigarettes, so that's an example of an excise tax. Now, the excise taxes that we're going to talk about in this video are ones that are like measured in dollars, not percentages. So like for example, if there's like a 2% surcharge on gasoline, we're not talking about a tax like that. That gets a little bit more complicated to compute. So we're talking more like every time you buy a gallon of gas, you have to pay a 25-cent tax, something like that we can measure in dollars. So a per unit excise tax is a tax paid for each unit of the product produced slash sold. And remember, we're dealing with perfectly competitive markets here, so if it gets produced, it will get sold. So the best way to illustrate these excise taxes is by using a graph. So we're going to imagine here the market for soda. And originally, this is just a perfectly competitive market, no government interference. And if this is the case, based on supply and demand, the market equilibrium price of soda is going to be $4, and the market equilibrium quantity of soda is going to be 4,000 sodas. So again, this is our starting point. This is our market without any government taxes, price controls, nothing, just a free market. Now imagine that for whatever reason, maybe they want to make people healthier, maybe they just want to make money. The government decides to put a $2 tax on every soda produced slash bought and sold, right? So in this situation, we have to figure out, okay, what are going to be the effects on the price of a soda, on the revenue that firms earn from selling soda, on the quantity of sodas produced, and how much money is the government going to make off of this tax? So there's a lot of questions to answer here, and there's a lot of more difficult ways to figure this out, but we're not going to use those. We're going to focus on an easy technique called the tax wedge. So to do a tax wedge for a $2 excise tax on soda, it would look something like this. So we're measuring our tax in dollars, and our y-axis, which is price, is measuring dollars. So we're going to take a $2 vertical distance, right? You see that? It's right in between 3 and 5. That's $2 of difference right there. So you take a tax wedge, the size of the tax, this is a $2 tax wedge, and you fit it right in between your supply and demand curves on the left of the equilibrium. So don't mess with this area over here. We're dealing with a tax, so we're going to put it right there. So this is a $2 tax wedge on soda. So what does that tax wedge allow us to do? Well, it's going to allow us to see how much buyers now have to pay for soda. It's going to see how much revenue sellers get from selling soda, and we're also going to be able to see what the new quantity of soda produced and bought and sold is going to be. So don't get into shifting any curves or anything like this. That's more complicated than you need to do it here. You can do those things, but we're not going to deal with that at this level. So the new price of a soda is not going to be $6, which sometimes students think, okay, so if it was $4 before, there's a $2 tax, now it's going to be 6. No. The new price of a soda is going to be $5. So if you take your tax wedge, find where it meets the demand curve, follow it over to the y-axis, that is going to tell you the price that buyers now have to pay for a soda. So this is the consumer's price per soda. Every time a consumer buys a soda, they're going to pay $5. Now, the next question is, every time a seller sells a soda, how much revenue are they going to get from that soda? Originally, they would have gotten $4 in revenue from that soda before the tax. And that would have been also the price buyers pay, right? Buyers pay $4, that means sellers get $4. But with the tax, buyers are paying 5. Of that $5 that the buyers are paying, 2 of those dollars are going to the government, right? So how much revenue is left over per soda for the seller to earn? Well, that would be $3. So you can either use that logic that I just laid out, or you can just remember that the tax wedge intersects the supply curve right there, follow it over to the y-axis, and that is the revenue per soda that producers get. So consumers pay $5 per soda, $2 of that goes to the government, the remaining $3 go to the firm. So, like I said, with the tax wedge, it's a nice, easy way to see what's the price buyers pay, what's the revenue sellers get, and it also is going to let us see what is the new quantity of sodas that are going to get produced. Now, originally, remember, before this tax, the equilibrium quantity of sodas was 4,000 sodas. But with this tax, the new quantity is going to be just 3,000 sodas. So we find, again, where the demand curve and the supply curve are touched by the tax wedge, go down to our x-axis, and there we can find the quantity of sodas with the tax. That's what the T stands for in Q subscript T, right? So quantity with tax. So that's some of the effects that this tax is going to have on the market. We're going to see a higher price that buyers pay for soda. We're going to see producers get less revenue. And we're also going to see a decrease in how much soda is actually produced and consumed. But there's one more effect. You have to ask yourself, how much money does the government make off of this tax? Well, let's think. How can we figure that out? Can you guys see it on the graph? Every time a soda gets produced, the government makes $2 in tax revenue. This is the government's tax revenue here. $2 every time a soda is produced. Well, how many sodas are getting produced? That would be 3,000. So the government's tax revenue is simply the area, length times width, of this blue box right here. And that should make sense, right? Because the vertical distance is $2, that's per soda. The horizontal distance is quantity, how much soda is getting produced. So price, tax times quantity is going to give you government tax revenue. So in this situation, if there are 3,000 sodas produced and the government gets $2 in tax revenue from every soda produced, that means total the government is going to be earning $6,000 in tax revenue. So that's how you figure that out. It's actually not too bad, right? So what are the effects of the tax? Just to recap here. Well, one, the quantity produced and sold decreases from what it was. Originally in this graph, it had been 4,000. Now it's less than that. Two, consumers pay more for the product, right? Three, producers earn less revenue from the product. And four, the government gets tax revenue. If you ever take a more advanced course, you'll also learn about something called deadweight loss, which is also a fifth result of this. But for now, just to focus on the idea that quantity decreases, price increases, and the government gets tax revenue. So why does the government do this? They're making things more expensive for consumers, they're making it harder for producers to get money, and they're overall lowering how much of something gets produced. Well, there's a bunch of reasons, right? First, think back to the circular flow model for a mixed economy. Taxes aren't just something the government does to punish us or for fun. They use those taxes to create expenditures, right? Things like paying households for their labor, paying firms for the products that they produce, right? Those are government-owned factors, government purchases. But then also remember there's something called a market failure. Public goods, which are neither rival nor excludable, would not get produced in the free market because of something called the free rider problem, which leads to a market failure. So the government steps in, forces us to pay taxes, and then fixes those market failures and gives us things like a military, right? Or public schools, things like that. So there are lots of reasons why the government taxes us because there are benefits for society overall when the government is able to correct for market failures. Sometimes the other reason is more simple than that, though. Sometimes the government is just trying to change people's behavior, right? So in the case of taxing gasoline, right? So every gallon of gasoline we use adds more pollution to the environment. And so if the government taxes that, they can maybe reduce the amount of gasoline that people are buying. Or cigarettes are incredibly dangerous. So the government puts a tax on cigarettes rather than banning them outright, making cigarettes more expensive and decreasing the quantity of cigarettes produced and sold. And then they actually use that tax revenue, the government's tax revenue, to pay for things like anti-smoking campaigns and advertisements, things like that. In the case of soda, the idea of a soda tax, which happened in Philadelphia and under Mayor Bloomberg in New York City, the idea was to get people to stop buying as much soda because it was having negative effects on people's health. So to change their behavior and to get them to buy less of something, the government put a tax on it instead. So there's, a multitude of reasons why the government might tax, but there's a lot of disagreement over how big the tax should the government be taxing this thing, and that's where you kind of cross into some political debates. But we're not really interested in that. We're just looking at the effects of taxes on perfectly competitive markets here. Hopefully that helped. Thank you for watching.